All right, here we go. Last assignment for the year is going to be an extra credit assignment that I have for you instead of a final exam. I figured that instead of a final exam, which we're not supposed to get finals anyway, I would give you an opportunity to do one last thing to improve your grade with an extra credit assignment on something called Pedigree Charts. Since we haven't gone over pedigree charts, I'm going to make this video so that you can see how pedigree charts work. And then you can work on the extra credit assignment, work on paper, take a picture of it, and then turn it in. So let me show you what this looks like in your online notebook. If I were to screen share it really fast. All right, so it says extra credit week 7. Give you a short description. Only one assignment. It's an extra credit assignment. Even though you're going to see it says extra credit 1 and extra credit 2. The extra credit 1 is really just for you to learn how pedigree charts works. This video is listed right here, so you can click on it and watch it anytime you need to see pedigree charts if you get confused on anything. And then the assignment 2 is really the actual assignment. And I have it all listed for you in order. So it goes over basically pedigree charts, which I'm going to do in this video. And then the situation with the assignment is that you're an investigator and you have found out some information on the person you're looking for. They have this blood type, they are positive for hemophilia, and they have a bent thumb. And so you map the family of the people you think it could be. So the first one is on blood type. This is a pedigree chart here. And then it asks you to answer numbers 1, 2, and 3. Based on learning from the pedigree chart, which we'll get into. Clue number 2 is that the person has hemophilia, which is a sex-linked trait. There's the pedigree chart here of the whole family. I'll show you how to read that. You answer number 7 and 8. You answer number 4, 5, and 6 up here, and then you answer 7 and 8 here. And then clue number 3 is thumb shape. This person has bent thumb or hitchhiker's thumb, which is a complete dominance trait. There's the pedigree chart for the family on that trait. And then you answer 10, 11. And so then you check the family for all the possible suspects. And you say, I think the person that did it that has all 3 of these is this person. You write their name. And then what did you basically get out of using a pedigree for? And so write a couple sentences on what you learned. Okay, so let's jump into how, when I give you something like that, what the heck is going on right there? So let's go take a look at that. So I'm going to do it with some notes, and then I'm going to do some practice problems off of this extra credit assignment for you. So if you're watching this video, good for you, because you're going to get some of the extra credit points already done here in the video. Okay, so pedigree charts. Probably seen the word pedigree before. I think of dog food called pedigree. The reason it's called pedigree is because when they breed dogs, they like to have the traits of the dog that they're looking for passed down from one generation to the next. So they're actually running pedigree charts for dogs. It's big business. You can make a lot of money doing that. All right, so what does a pedigree chart represent? What does a pedigree chart represent? So what are all those boxes and squares and lines that you saw? What it represents, it is a family. It's a family of people, obviously, for a given trait. And the more people you can get, the more information you'll be able to pull out of it. So not only brothers and sisters, moms and dads, grandmas and grandpas, you want to get aunts and uncles, nephews, cousins, second cousins, as many people as you possibly can. The people they married, the kids they had, everything. All right. So what kind of traits could you look for? You can look for any trait. So like we could be looking for eye color. You can have an eye color pedigree. Or you could have hair type pedigree. Wavy hair, straight hair, curly hair. You can actually see who are the people that have made the hair that you have in your family. We used to do a project with this where you'd actually map out your own family and then pick a trait. It was a great project. It was fun, but digitally, I just thought it was too much too fast and would just mess a lot of you up. So we didn't do that project, unfortunately, but it is typically something we do in biology. All right, why do we need pedigrees? Why do we do this? Well, what pedigree charts can tell is they can tell you, you can track a gene, you can track genes being passed through the generations. For instance, there may be like blue eyes, like all of a sudden somebody in your family has blue eyes, and you're like, whoa, whoa, everybody in my family has brown eyes, and now all of a sudden somebody's got blue eyes. Where'd that come from? You could actually map it and figure out where did it actually come from. Who was the person who gave it to them? But you can also even make this bigger than just one person's family. You can use this across many, many different families, and you can use this to help understand the frequency of diseases like hemophilia or color blindness, and why some people have the traits and why some people don't. So you can even connect this to the coronavirus, possibly. We don't know much about the coronavirus yet, but if somebody were to be more immune to the coronavirus, it could be because of the DNA that they have that doesn't allow the virus to cause such bad symptoms and cause things like, really severe headaches, fever, and possible death in certain people. Whereas in other people, their DNA allows the virus to have more of an effect on their body. And so we could use that information to find things like antibodies or vaccines or anything that we could use as a treatment for the coronavirus. And this could go for any kind of bacterial infection or viral infection. The more you know about how the people are passing genes and DNA along, the more you can learn about how to use that knowledge. Okay, so how do you read a pedigree chart? How to read a pedigree. Okay, you basically get three different kinds of lines. Okay, the first thing is you're going to have boxes and circles. Okay, the boxes are your males, the circles are your females. The way I best remember that is I just think guys, we're really stupid, so I just think of guys as blockheads, and that's the way I remember that they're always the squares, they're blocks. So the guys are blockheads is the way I think about it. All right, so typically you'll get a male and a female. What does this line mean? This line means that they are having a romantic kind of relationship. They got together, and you would only do this if you're going to draw another line that comes straight down from that line. Notice it doesn't come straight down from a person. It comes down from the line in between them. What does that mean? This male, this female got together, had kids. This male, this female got together and had kids. Okay? So we're going to give these people a name. We'll call this Joe, call this Nancy. Okay. So you go straight down, and then this is their kid. So these people got together, had this kid. This kid is a girl. We're going to call her Sarah. Okay. Now, if they had just one kid, it would look like this. Joe and Nancy got together, had a kid. And then let's say they had more than one kid. Well, then you would do a cross line here, and then the line goes down to each kid. So let's say they had a boy, Alex, and they had another girl, Hannah. So Joe and Nancy got together, had 1, 2, 3 kids. Okay. Now you might say, and then this happens in today's world all the time. Well, maybe Joe had another kid with a different woman. How would you do that? Well, you would draw another woman over here. Let's call her, I don't know, Maria. They got together. They had a kid. Let's say, give him a girl. I don't know, Alexis. Okay? So Alexis is a half sibling with these 3 siblings, right? Because they share the same father, but different mothers. Well, then these kids grow up and they might get married. Let's say Hannah meets a guy, and together with this guy, so they get together, so they have a straight across line, and down below, they have a kid. Let's call this person, all right. Let's see, who was Hannah's husband? Max. Let's try that. Okay. All right, and you can see how this continues to grow and grow, and then the brother, you know, like Sarah had a guy and they had a kid, and Alex got together with another girl and they had a kid, and Alexis got together with a guy, and this just grows and grows and grows and becomes a huge old family. But the thing to remember is the cross lines mean they got together. The down line from the cross means these two people formed that kid. And then if there's a cross line where they're down off the cross, like boom, 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 then they're siblings. So up and over is a sibling. Straight across means married. So I used to have students a lot who would draw, when we draw the family project, they would be like, all right, so there's me, and then there's my sister, and then there's my brother. And they would just drew this. And it was like, that's bad. That means you, your sister, and your brother got together and had kids. That's not possible, nor is that highly recommended. So don't draw it that way. You have to be up and over for siblings, up and over for siblings. It's very important you put them that way, because you could be drawing the wrong thing for people. Okay, so that's the best way to measure. Now, the other thing you will see is sometimes there's shading going on. So there might be a person that's shaded in. Let's shade in Hannah. Let's shade in Jorge. And usually the shading means the person is either affected with the disease, so they have whatever the disease is, or the recessive trait. But usually they'll give you more information. They'll give you more information about that when you're doing an actual problem. Okay. And then what do you use this for? Then you go back and you start finding the genotypes, the letters that go with each person, because the shading will tell you the phenotypes, and you got to go back and figure out the genotype. So let's jump into a problem as an example. This will really help.